Hello everyone, today I'll be discussing the spring force, which is one of the restoring force that occurs in an elastic body. Now first of all, what is an elastic body? Now an elastic body is a body in which if we apply any deformation or elongation, then it will regain its original shape. Say for example, you have a spring. Now spring, if you apply a force on the spring at this point, then the spring will get elongated up to a certain point. Let me draw the spring again. It will elongate it in such a way that it reaches to this point. Now, due to this force, a restoring force is developed on the spring such that it acts in the direction that is opposite to this force. Now this is the direction where the restoring force acts. This restoring force, that is Fr, is directly proportional to this change in this length. Now there is a negative sign because the restoring force always acts in the direction opposite to the force that is causing the deformation. So to remove this proportionality sign, we need to multiply it with a constant that is known as the spring constant, that is given by K. So now this is the spring force that exists in a elastic body or this spring. Now the second point here is that it exists in an elastic object. So the spring force is, you can say, it is elastic in nature. Now the nature of this force is also electromagnetic. Because the spring is also made out of atoms, and between atoms electromagnetic force exists. Now this was a case when the spring was getting extended. Now there is another case where the spring might get compressed. So in this situation, the length of the spring will decrease by a certain amount. Now it can be demonstrated in this manner, so that the spring has become compressed and has reached to this point. In this situation, the direction of the compressing force is in this direction, and the restoring force is developed at this spring such that it is acting in this direction. The value of this restoring force is also equal to this value. Note that in this situation, if you take this change in x, then the force magnitude needs to be considered, and the vector equation can be given as equal to kx. This is a displacement vector. This x vector is a displacement vector, such that if it is getting extended, then the vector is pointing in this direction and the restoring force is pointing in this direction. And this change in x is nothing but the difference between the initial length and the final length. Now in this situation, if this was the initial length, x1, and this is the final length x2, then the change in length is equal to x2 minus x1. Now let us take this case where we have a spring, and at the end of this spring there is a block, such that the mass of this block is m1, and also there is another string connected at the bottom of this block, and another block is hanging by this spring, such that the mass of this block is m2. Now in this case, first of all you need to analyze the lower block. and try to isolate the block. Now we know that the weight of this block would be acting in this direction such that it is M2G, and a tension force would be developed on this spring such that it is always pulling in nature. Now this block, if you isolate this block, then there is a gravitational force acting in this direction and a tension force acting in this opposite direction such that it is trying to pull the block. Also, if you take the case of this other block, and in that situation the mass of this block is m1, there is a gravitational force or the weight acting in this direction. Also, the tension developed due to the presence of this string would be acting on the block such that it will try to pull the block in this direction, and the spring has to carry the weight of this block. So the restoring force, the weight of this block is acting in this direction, the restoring force developed on the spring would be in this direction, so that it is equal to Fs. So this is the free body diagram of this mass 1, and the free body diagram of this is this. Now here you can consider the condition of static such that the net force acting on this body is equal to 0. That is, tension is acting in the opposite direction, that is why it's positive T, minus this weight is acting in this direction is equal to 0. So tension is equal to mass to G. Also, if you consider this situation, then you can also use the same sum of all the forces, external forces is equal to 0. So the restoring force is acting in this direction, that is F of S, minus weight of this block is acting in downward direction, as well as this tension is acting in this direction, so it is equal to 0. We have already found out that this tension is equal to M2G is equal to 0. This means that if you take this in this side, then M1G plus M2G, so this is equal to M1 plus M2G. This means that the restoring force, the spring was actually supporting the weight of both the blocks, such that the restoring force that is developed on the spring is equal to the sum of the weight of these two blocks. Now let us investigate this situation where we have springs in series. Now let this be one spring which is connected in series with this another spring, and the spring constant for this spring is K1, and for this spring it is K2. Now we know that if we apply a force in this direction, then this spring will try to elongate, and due to that there is a restoring force developed on this spring which will act in this direction, and it's given by K1, K2, X2. And due to this restoring force, there is a reaction developed at this end such that this other spring will try to get elongated, and this force will also be equal to K2, X2. And due to this force, again there is a restoring force that is developed on this side of the spring such that it will act in this direction, and the value is equal to K1, X1. And finally again the same due to this a reaction will be developed at this point, and that will be equal to K1, X1. Now in this situation, the force that is acting is same. This force K2 x2 needs to be equal to K1 x1, because this point has to be in equilibrium. If this force is larger than this, then there will be this spring will move in this direction, but that is not the case, because this point has to be in equilibrium. So K2 x2, this force K2 x2 needs to be equal to K1 x1 by equilibrium. So, and again the total elongation, that is x, is equal to x1 plus x2, the elongation on this plus the elongation on this, that is the total elongation. Now we know that this formula, that is F is equal to kx minus kx. This is the restoring force that is developed. Now if this is the total elongation, then we can write this as x can be written as F by k. It can be written in this way. So this is the total elongation, so this can be written as force per unit K equivalent of both the springs, that is equal to, for this one it will be F by K1 plus this would be equal to F by K2. Now if you cancel all the forces, this has to be actually minus, but I have not taken negative sign because all the term in this equation is negative, so we can neglect this negative term. So that is why this will get cancelled, and the equivalent spring constant, now this is 1 by equivalent spring constant would be equal to 1 by K1 plus 1 by K2. So this is the formula for the equivalent spring constant in case of two springs that is connected in series. If there are more number of springs, say for example there are another spring that is connected in series, that is K2, K3, many springs are there, then in this equation it will be added up, plus 1 by K3, like that. It will go up to any number of springs that are in series. Now we have another situation where the springs are in parallel. In this situation, now if there are two springs that is in parallel, then if we apply a force in this direction, then the spring will both the spring will get elongated by a distance of x, and let the spring constant for this be K1 and this be K2. Now in this situation the elongation for both the spring would be equal, that is x1 is equal to x2 will be equal to x, and the force, due to this force there will be a restoring force that is developed on this spring, that is K1x, and in this spring K2x. Now this force F, by equilibrium we can say that this force F is equal to K1x plus K2x. If you take this, and this can be written as K equivalent into x, K1x plus K2x. This all the x will get cancelled, so K equivalent in case of the springs in parallel can be given by the equation, that is K1 plus K2.